Hi, everyone. My name is Michelle Gutzait, and I'm a Microsoft Data Platform MVP. I work at EPAM. We are an engineering firm doing development, databases, analytics, machine learning, artificial intelligence, migration to the cloud of the entire stack, and more. So I've been a DBA, a SQL Server DBA for many, many years. And very often I hear from developers saying, hey, my SQL Server database is not performing well. So I decided to create this presentation, especially for developers and database developers, to discuss some of the main coding best practices and also explain and show how you can understand better what SQL Server does behind the scenes and be able to compare between different solutions to the same problem and decide which one is better. Now I'm going to be here answering questions if you have in the chat interactively. So any question, any comment, I always like to learn as well. I'm sure that I did not cover all the best practices in the world, just from my experience. So please feel free to ask anything and comment if you'd like. So let's have fun. This presentation is mainly for developers using databases. So if you're a front-end developer that wants to understand how the database works, that's for you. Database developers could be the same team that is developing the front end, could be also on the back end. For DBAs that are doing performance tuning and would like to learn or would like to learn more about how to do performance and tuning of specific code in case it needs a rewrite or adjustments. So you actually need a little bit of knowledge of Transact SQL and database design. So I hope you will enjoy. And what do we have here in the agenda? So I'm going to introduce the team and the environment. I'm going to talk about the main rules of database development from my perspective, from my experience. I'm going to talk just high level about the application side performance best practices. And I'm going to talk a lot and detailed about database side performance best practices. And I'm going to, while I'm talking about the performance best practices in the database, I'm going to also show some real-time, real-life examples. And I will not have time to show everything that I've prepared. So let's take it by the ear and see how much we have time to do. Basically, after this presentation, you will be able to use the right tools to compare between different scenarios and different code and how it will behave against SQL Server. So first of all, I'm Canadian, so we like hockey, and let me talk about the team comparing to the hockey team. So in hockey, we have the forwards that are in the front, and I would compare this to the user interface, so front end. The user interface is doing things and sending requests to the front end, to the database side, and then we have the database developer that has to write that code. Could be the same team that does front end and back end, so database development. But also from the user interface perspective, you need to understand how things are working, and we will touch that later. So you have the database developer, and then at the end you have the DBA that has to make sure that the SQL Server instance and the SQL Server environment is properly configured, is optimal, is being properly maintained, and sometimes has to also do some performance tuning, either general performance tuning or specific when there is a problem and others are not able to understand what is going on with SQL Server. And this is for the team. So this presentation is for everyone that needs to make sure that the code is performing properly. Let's talk about the component of the environment, and I will explain why is this important. So let's assume that we probably have legacy applications with client-server applications. So we have the client machine that maybe you have an application installed on the client machine, and it's important to make sure that this machine has enough resources to handle whatever it needs to handle. Usually in the newest applications, you're going to have a web server. So the client is just going to use a URL for the application. So you have the web server, and the web server will probably connect to an application server, or the client can connect directly to an application server, depending on how your environment is set up. And so those machines can be on either virtual machines or physical machines. So if it's a virtual machine, you also have another layer where you have the host, and you have the actual operating system of the either web server and application server. You have all the network in between, and then you have the database server as well that could be either in the cloud. So it could be a virtual environment in the cloud where you have SQL Server virtual machine with SQL Server installed, or it can be just a database in the cloud, which could be Azure SQL Database or RDS, for example, if it's Amazon. Or it can be also either on a physical box or a virtual box, and all the network in between. So if we're connecting to the cloud, it means that we also have another layer of the network to the cloud. So we need to make sure that everything is properly configured. And now let's see, why is it important for us? Remember that when we're developing with SQL Server can reside anywhere. So physical or virtual machine in on-prem, it could be a virtual machine in the cloud, or it can be a PaaS solution, just a database in the cloud. And nowadays, we don't know eventually where this our database will reside, because we may do migrations to the cloud or back. So we need to make sure that it will perform properly no matter where it is. So what's important for us from the environment side is that the application server and that touches the database code, it's important. It's important for us because of the way it will send requests to the application server. So the application itself, or to the database server, sorry, and the application itself is very important, and I'm going to touch a little bit about that. Then we have the network in between all the environments, especially between the application server or the web server and the SQL database, because all the requests are going back and forth in there. It's important for us, the setup of the physical and the physical machines of SQL Server, where SQL Server instance is installed, and if it's a virtual machine, then also the host server, if it exists. And the most important thing here is also the storage and the storage configuration, because as you know, I/O is the most expensive operation, especially when it goes to the storage. So when we're querying physically from the storage and writing to the storage, this is the heaviest operation, meaning that this may cause performance degradation when we're writing or reading from the storage. So the entire environment is very important for us, even if we're just developers, because we need to understand that whenever we're doing something in the database, for example, from the front end, it will go all the way and have all those tiers. And I'm not even talking about security and encryption and stuff like that may occur along the way, that are also very important and may degrade performance. So we just need to have this in mind. So what does it mean for us? We need to ensure that there's not a lot of back and forth between the application and the database, because that way, when we send requests, get back information, send another request back, this is resource consuming, and it goes across the network and may cause performance degradation. So we need to minimize that as much as possible. Also, we need to minimize the amount of data that is going to go to the database and back, right, for the same reason. So let's say if we only need 3 columns out of 50, we're not going to query all the 50, because we want to try to minimize the amount of data that is going back and forth. In terms of intensive data operations, it's much better if, let's say, you have a job that is very intense and has to do a lot of stuff on the database. So it has to write and then read data and then write the same data. It's always better to keep those type of jobs or those type of processes as close as possible to the database, because you don't want the information to go back and forth to an application server or to an application. You want to keep those very close to the database. The database code, we need to make sure that the database code is using as less resources as possible. Okay, so indexes if possible, you know, less I/O, less memory, less CPU, as much as we can, right? Sometimes we cannot avoid, but if we don't need to do something, we should not do it. And this is especially I/O. Like I said before, we never know when the data is going to be in the cache already. We also need to make sure that when we have multiple database on multiple instances, we work with this with caution, because some of the operations would be lighter if we just connect to both databases from the application and not using, for example, link servers between the instances, because link servers, the local optimizer does not know the remote optimizer, and vice versa. So sometimes operations with link servers are going to be much more expensive. So we need to be very cautious with what we do when we have multiple instances and multiple databases under different instances. We need to make sure that we handle connections properly, because every time you open a connection and you log in, resources are being allocated to your connections, and this is resource consuming. So we need to make sure that we're handling connections properly. So those were my tips on the application side, and let's try to go a little bit into the details. But before we start, I would like to give you some three main rules when it comes to database development. So my first tip is this: the fact that you can does not mean that you should. You see this little guy? We can steal, right? But it doesn't mean that we should, because we may end up in jail. So it's the same with the database code. Many times I'm being asked, you know, we have this option, why shouldn't we use it? Because the fact that you can doesn't mean that you should. And I'm going to show some examples or talk about some examples of that. My second rule, or 2 cents tip, is always try to design where in your mind the database is going to be huge and there's going to be a lot of volume. And why am I saying that? Because I've seen in my many years of being DBA, I've seen applications that started very small. Let's say you start with 1 client or 2 clients or 5 clients or 10 clients. And then over the years, it grows to be, and you have 100,000 clients. Then everything that you've done and you thought small may not work when your database is huge and you have a big volume of transactions. The problem is, you know, we want to do things fast, but it's not always good, because going back is much more expensive. So if you have performance issues now and you have to go back and start rewriting, it's going to be very expensive and very tiresome for you and for the organization where you work. So it's going to be very expensive for them. So always try to develop with a lot of data in your mind. My last rule is, you know, we have a tendency to patch, right? We need, let's say we found a bug and we need to do things fast. So we just do something temporary, we're patching. But remember that everything that is temporary will probably become permanent, because nobody will have time to go back and fix, not you and not somebody else. And whatever you did once, most probably you will do it. You will keep doing it because it will become a habit. So try to make sure that you have good habits and you make them permanent instead of temporary patches. So those were my 3 tips. And I wanted to remind everybody how the SQL Server Optimizer works. So the requester is sending T-SQL code, so submits to the SQL Server instance or the SQL Server instance. What happens is that the optimizer validates the syntax, meaning that all the commands are properly written, all the objects exist, and everything is good to go. Then the compiler checks if a plan exists for that specific code. If it exists, it will use it. If it doesn't exist, it will build a plan. So this phase can be time-consuming and resource-consuming because the optimizer will have to build a new plan. So your best bet is if the plan already exists and you're reusing a plan that already exists, with some exceptions that I'm going to talk about. When the plan exists in the cache, the engine executes the plan and requests for the data. So the data can either be retrieved from the cache, which is the best scenario, or from the storage. Bringing data from the storage is maybe time consuming and resource consuming and may result in performance degradation. So, and then when the data, so the data is retrieved from the storage to the memory if it's not there, and then it's being, the results are being returned to the requester. So why is it important for us? Because every time we send a command to the database, it's going through that specific process. Okay, so we need to make sure that, you know, especially for code that is running constantly and frequently, we need to make sure that we minimize the you know, the resource consumption, basically. Let's talk a little bit about the application side best practices, and this is really high level, and you probably have a lot more. But from my point of view, is talking about ad hoc queries versus store procedures. I know a lot of organizations and a lot of development teams would like to have applications that are database agnostic. So the problem is when you're not using the specific features of a database, you may this may result in performance degradation. For example, with SQL Server, if you have repeatable code and you're not using store procedure for it, it means that it's going to be compiled and recompiled. So now as the version of SQL Server are higher, the optimizer becomes better and better. So sometimes, you know, even if you have ad hoc queries, they may be recognized and already have the plan in the cache, but not if your code is too complicated. So you need to monitor this case and make sure that things are not being recompiled or rebuilt every time you run. Let's talk about dynamic creation of queries. So sometimes you give the user a lot of power by deciding what type of information is going to be returned from the database. So as much freedom as you give the users or the code, it may result in performance degradation because you get different queries every time, totally different queries. So for sure the plan is not going to be in the cache, and SQL Server is going to work very hard in creating the plans. And you also have to be very diligent about the ability of the user to enter a SQL injection, but that's a different story. This is best practice, but not performance best practice. We need to make sure that we're not doing a row-by-row processing against the database because SQL Server is a set-based, and this is how it performs the best and not row-by-row. So we need to actually make sure that this is not happening. I've seen, so for example, if you're using client side cursor, you need to make sure that you understand how it works and that it's actually the right way to go in that scenario. Sometimes you cannot avoid, but sometimes you can. So row by row processing is a no-no in SQL Server. Another problem that could be is not using connection pooling. So connection pooling makes sure that because connecting to the database and making a login is resource consuming, connection pooling makes sure that the connections are being reused and it doesn't log out every time. So you have a connection and then requests are being sent over and over again over the same connection, so you don't have to reconnect to the database. So this is very important. But I've seen also cases where the connection pooling was not properly set. And for example, you may have more logins than logouts. So this is not a good situation. You need to monitor and make sure that this is not the case, your case, that you're using the connection pooling properly. So those were from the application perspective. You may have some additions or comments. I'm always happy to learn. Let's talk about database side of things, and let's play a little bit. So I do have 10 slides of best practices, and hopefully we already have 20 minutes over. So let's see if in 40 minutes I can cover everything that I wanted. So let's start. So the first one is select star from. So as you remember, select star is problematic. Why? Because it's going to bring all the information. So this is a good thing for if you're lazy and you don't want to actually write the column names. But if anything changed, for example, if somebody added a column or removed a column, this may fail for you. But from performance perspective, it's also going to bring probably too much information. So you want to actually write the specific columns that you would like to retrieve, so that you make sure that not a lot of data is going over the wire. So when you query unnecessary columns, okay, SQL Server will bring you everything that you've asked for, but sometimes there is something that is called covering index. Covering index means that you have an index that already includes in it all the columns that you're using in your query. So for example, if I have an index on 3 columns and I'm only using those 3 columns in my query, SQL Server doesn't have to go to the table and retrieve everything. It can just use the index. So covering index is performing much better than going and retrieving everything from, or retrieving information from the table itself. So I'm going to show some examples of this. Always try to use set-based set-based commands versus the row-based. Okay, so cursor, while loops, try to avoid them. Better to use set-based commands. Cursor. So cursors, it sounds like, so if I ask you what's the difference between a while loop and a cursor? So because of SQL Server history, the way that cursor works is that you retrieve data into the cache and you place locks. Depending on the cursor, you place some locks on the data. So you open the cursor and then you need to work with a set of data. So you do have a place in the cache where you have the data, and then you have to go one by one and do something, row by row and do something. So because of the way SQL Server works, usually cursors are going to perform worse than a while loop. But again, try to work set-based, and I'm going to show you examples. So let's have fun. Let's go back. Let's go and see what we're doing on the SQL Server side and have some demo. So for this presentation, I've created a table with 2 columns: ID integer, not null, and name call varchar 100, not null as well. And what I did is I populated, this is bad practice, but it's only for the example, I populated the table with 10 million rows. So what I did is I'm inserting the ID with a number from 1 to 10 million and some start value in the name. So all the names are the same and the name is 10 characters long. Okay, so if I write sp space used and my table is called big table, just let me go to the right database. So I see, you see, I have I can see the size of the database, the table, the size of the data, the size of the index. Okay, so I can see how many rows I have. So this is a table. Let's add a primary key. So because I entered the information from 1 to 10 million, the information is already sorted. So this is why the creation of the primary key is going to be very fast, because the data is already sequential the way I entered it. If I would have entered non-sequential, the sorting of operation would take much longer, and then the index would be created much longer. So this is going to take a few seconds, like you saw 2 seconds. And now I want to check again what's the size of the table. So as you can see, okay, I have more. I have less reserve, but the index size is much bigger now, okay, because I have a clustered index. So this is important, you see. So when I have a heap table, when I have a primary key, the amount of reserved is smaller, even though I increase the index size. Okay, let's proceed. So I'm going to add few columns to that table. So I'm adding description, some number, current date with the default of get date. I have this is get date, right? Otherwise it will not work. So I'm going to add those columns because I want the table to be a lot more than just 2 columns. So now I would like to update the name column to something else. Okay, so for example, name underscore and the value of ID. Okay, so I'm going to do that. So this is a set-based operation on 10 million rows. It's going to take 1 minute to do. And what I would like to do next is I would like to create an index on the name column. Okay. Just for your information, unique index will always perform better because SQL Server will know that there's only one value of each. But in this case, I'm just going to create an index. So it took me 20 seconds to create on 10 million rows. Okay, so to update. Now, let's create the index on that column because I would like to show you a few things with that index. So the index is very fast because it's probably because it's also sorted. So let's check how many rows, because it's a character. I would like to know how many rows between name 1, 2, 3 and 1, 2, 3, 4, 5. Okay, let's see how many rows. And I would like to know also between 1, 2, 3 and 3,000. Okay, so it's not numeric, so it would be calculation of character. So you see the first one is returning 5,000, around 5,000 rows, and the second one around 2 million rows. Okay, so why is it important for us? Let's see. Let's try to see what is going on. So I'm going to do an estimated show the query plan, and I would like to actually run it and see the statistics. But let's first just do select star for the 5,000 and for the 2 million. So if I go and I display estimated execution plan, you see that the first one has 0 weight compared to the other one. Why? Because the first one is only 5,000 rows. As you can see, it's using the index that I created on name call. And it has, because I'm doing select star, it has to go to the clustered index. The clustered index at the end, the last leaf, contains the entire table, all the columns. So clustered index will be heavier because the last leaf contains all the columns of the table. Okay, remember that. So it has to go to the clustered index in order to bring all those columns. What will happen if I just retrieve the name call? So you see, I have the where clause. This one is going to use the index, and I'm talking about the one with the 2 million that returns the 2 million rows. So if I do this, what will be the estimated execution plan? It's going to be covering index. Why? It doesn't have to go. So it's the same query as this one, but no select star. just a name call. So my index already contains all the columns that I need. And this is why you see that this is a covering index and it's going to be much faster. So if I look at statistics, okay, let's just make sure that I don't have set statistics time off because I don't remember what I did before. So statistics IO on, okay, and let's see what is coming. So we're going to see how many reads we have for each one of those. It's going to execute for a little while, and in the messages we're going to see. So the first one is already being returned, 5,000 rows. And you see, these are the logical reads that happened because everything is already in memory. My laptop is a nice laptop. So I don't have anything, everything is already in memory. So if my query is going to the physical disk, I will see physical reads. Okay, so this is another thing to look at. So you see, the first one, retrieving 5,000, is only reading the table once, but everything, because it has to go to the primary key. The second one is also going and doing retrieving 9 times. It goes 9 times to the table, and this is how much, right? Because we have 2 million rows. The last one, because it's a covering index, look at this. So only 6,331 reads and only once. So this means that the covering index is much, much faster, right? So in this case, I showed that this select star will take a lot more than select just a column from the index. So that's a covering index. And by the way, covering index, even if you have included columns and they're part of your query, still the index will be covering index because it will retrieve the columns from the included columns. That means that only the included columns are only in the last leaf of the index. So you're good. Doesn't have to be all the columns in the index keys themselves. Okay, so we saw select star and covering index. Let's continue. Let's talk about row-based versus set-based. So this is a little loop that is updating the column sum number with ID plus 500. Okay, and it's going from 1 to 100,000 rows. Okay, so it goes row by row. Okay, let's see how much time it takes. Let me just stop this. So let's see how much time it takes. It should take a few seconds. Okay, so I'm just updating 100,000 rows row by row. So it should take maybe 10, 15. Okay, it took 7 seconds. 7 seconds. Okay, let's do the same thing, just a different range. Okay, let's even put this so it will be the same. Okay, so update, same thing, ID plus 500. This time another range, also 100,000 rows. So how much time do you think this will take? Very quickly, right? It's a set based. Let's do the same thing, this time 3,001 to 400,000. Again, 100,000 rows. Let's see how much time this takes. This is a cursor. So do you think it's going to be the same as the while loop or more? Let's see. And all this information is not in the cache. I could have cleaned the cache before to show you, but this is going to take around 15 or 16 seconds. Okay, so it took 10 seconds. So as you can see, the while loop is faster. Okay, what will happen if I take all those and I compare the execution plan? So as you can see, the while loop is 0%. The update is 69%. Okay, and the cursor is 30%. Make sense? No, it doesn't make sense. because SQL Server is not able to estimate the total of the execution plan. So in this case, looking at the execution plan will not help us. We see that the cursor takes much longer, right? So sometimes the execution plan does not give us any clue. What you can use, you can include live query statistics. I'm going to show in different examples, and you can see exactly what is going on. Okay. Okay. So we saw also set-based versus the row by row. Let's move on. Number 2. Just give me a second. Checking the time. So next best practices: avoid functions and user-defined functions in a where clause, and be careful of cross-apply. What happens is that if we're using functions in the where clause, SQL Server does not know the result in advance. For example, if the function is on the column side in the where clause, SQL Server will not know the result in advance. Hence, it will not be able to use an index. Same goes to cross-apply in specific situations. So cross-apply, you can do cross-apply with a function that returns a table. So if SQL Server does not know in advance what will be returned, the optimizer may make bad decisions as well. So if you're thinking about using cross-apply to a tabular function, you need to make sure that it's the right thing to do for your scenario as well. We talked about using store procedures versus ad hoc. So store procedures are compiled and ad hoc not always. So it really depends what you're doing with the ad hoc. If you have a query that is running once an hour and is not very resource consuming, it doesn't matter a lot. But if you have something that is constantly running and requires the plan to be in the cache, it's better to use a store procedure for that. Let's talk about parameter sniffing. Parameter sniffing, it means that, and I'm going to show an example, it means that when you have a store procedure, the first time you run it, the plan is in the cache. And sometimes for the second time that you run it, the plan is not the right one, okay? So we're going to see a scenario like that. So store procedures are not always the best, and I'm going to show the solution for parameter sniffing. Another very big tip is try to avoid using the percentage, the wildcard, at the beginning of the string, because SQL Server will not be able to use the index. If you need this along with other wildcards or other textual searches, just use the full text search for that. So this is a big topic. I'm not going to show an example, but I'm going to show you an example how come SQL Server does not use the index when we have a wildcard at the beginning of a string. And let's go back to the demo. Hope you're having fun like I do. So let's see. So for example, are we using the index? For example, do you remember we have an index on name column? You see we have a wildcard at the beginning. So what will be the execution plan? You see the clustered index is being scanned. So the clustered index on the ID is being scanned because SQL Server is not able to determine which is the actual name column that we need because of the wildcard at the beginning. So it has to scan everything. So this is an example. Another way to look at it is when we have a function in the where clause. So you see the function is on the column. So obviously SQL Server, even though this is very straightforward in our mind, SQL Server does not know the result before. So this one, what do you think? Will it use the primary key? yes, it uses the primary key because even though it's one value, it uses the primary key because it cannot know the value in advance. And what will happen if I query here the column name? What do you think will happen? Let's check. So you see, it's using. Why is it using the index on the name column? Because this is a covering index, so it has to scan the entire table anyways, but it figured that it's better to scan the smaller index only on the name column rather than scanning the primary key and the entire table. So this is another example of a covering index. Okay. How would you resolve this? So the idea is to make sure that the function is on the side of the constant and not on the side of the column. So if we do this, you will see that now it is able to seek the index on the column and then just go and look for the select star. Again, if we only need the name column, it will be another index, covering index. Let's talk about the parameter sniffing. Okay, so I created this store procedure. Let's make sure that it doesn't exist. I'm creating the following store procedure. I have a from and a to, and I'm going to query from the big table where ID between from and to. Okay, so this is the store procedure. So let's see those cases. Okay, I'm going to query only 2,000 rows the first time. That means that the plan is going to be created for small number of rows. Then after that, I'm going to query with a big gap. So this is everything, right? So that means that this plan may not be good for here. So let's see what will happen. So we're executing the first time. Okay, so I have to execute because the plan is going to be there. It's not just estimated. Okay, so the plan is here. Let's just actual plan. So I'm going to do it again. Okay, so the actual plan is clustered index is going to be used because it's the ID. Okay, so it's going to the clustered index. Let's see what happens when I do the same thing here with bigger. Okay, so let's see what happens. So you know what? I'm going to modify this store procedure to only retrieve the ID. Yeah, no. Okay, so let's see what happens. This is a bigger gap, right? So I'm going to execute. Still executing. And we're going to see. So now in this example, the SQL Server had to use the primary key anyways, because we're doing select star. So it has to use the primary key and the clustered index anyways in both of them. Okay, but here the execution plan was to retrieve specific rows, right? So now because we're using a bad plan, it goes and it does the same thing as if the gap was short. Okay, so it's retrieving 2 million rows. Let's see the execution plan. So it's going to do index seek. If we want to see what's the difference if we do with recompile. So with recompile means that I would like you to compile the store procedure for this specific execution to see if anything is different. Okay, so if I run this, it's going to run for 2 minutes. So let's see. So because here we have clustered index seek, let's see what happens if we run this, and it will run for around 47 minutes because we recompile, so for 47 seconds, because we're recompiling and we're checking if the execution plan is still the same. So let's wait and see what will happen. So what do you think will happen? I think it will still be an index seek, and it's still going to be the same time. So this is probably not a good example to show the parameter sniffing, because we would probably have to create a store procedure that is using a covering index to show, right, to show the different execution. But I'm just showing you that that this could happen, that the execution plan is not the same, and how to resolve it. Okay, so clustered index seek, we had the same one even after compilation. So that means that with recompile doesn't help us. However, if I had name column here and name column here, maybe we could see a difference with parameter sniffing. So just showing you how you can do. So we've seen index usage with the where clause and parameter sniffing. Let's go back to the best practices. Let's continue. So large row set updates versus while loop in delete and updates. Let's say that you need to delete millions of rows as history. Okay, so like I said before, a set based is better than row based, but in some cases where you need to, for example, update or delete a lot of rows, it would be better to just update or delete in smaller chunks, for example, 10,000 or 100,000 rows, instead of deleting or updating a huge chunk of data. And why? First of all, the transaction log is going to be growing because you have huge transaction. And also other processes may be locked and blocked because you're trying to delete and update a lot of information. However, sometimes you may want to keep your transactions so that the entire delete and the entire update is going to be in one transaction and you have no choice. But if you do have a choice, try to just have a while loop to delete and update in smaller chunks to avoid locks and blocks and to prevent the transaction log of SQL Server of the database from growing. Another tip is to use truncate table versus delete all the rows. So truncate table is also going to be, it's not logged, everything is not logged in the transaction, but you can still maintain the transaction granularity. So instead of deleting everything, you just truncate the table inside the transaction, and it's going to be fast because it's a DDL and not DML operation. This is a big one. Try, instead of creating a table and inserting data in your code, it's better to do a select into. Select into is non-logged operation, so it's not going to be logged like the insert in the transaction log, and it's going to be very, very fast. Now, sometimes you want to create a table with specific data types. When you do select into, you can still do select, convert, use convert, and then that column is going to get the type that you put in your convert. And I'm going to show an example. And a lot of times I'm being asked, what is better, table variables or temp tables? So now, before SQL Server 2019, what happened is that SQL Server would not maintain statistics of the table variables. And so maybe it would assume 1,000 or a few thousand of rows in table variables. And this is why the optimizer would sometimes not make the right decisions when your table variables would include many, many rows, okay, more than thousands. Since SQL 2019, and I posted the link here, the optimizer SQL Server maintains better statistics of the table variables. So it became less of a problem. The problem with table variables is that you can only create a table, but you cannot create indexes after. So sometimes if the information grows, let's say that you're inserting data into a table variable, and eventually you do need an index when you're joining with other tables. You cannot do that with table variables. And basically, table variables and temporary tables are more or less the same, because the people think that table variables are in the cache and they're not being written to the disk. But SQL Server is handling both the same. If it runs out of memory, they are both going to be flushed into the tempdb. Okay, so you will see both of them. The real difference between them is the table variables, they live only during your session, while inside your code until you execute, and temp tables during the connection, during the session. So I would recommend usually using temporary tables because you can add indexes to them. So really, depending on your scenario, I would say use the temporary tables, but there will be scenarios where you can. For example, if you want to send a table as a parameter to a store procedure, you have to use the table variables, obviously. Let's look at the demo. So select into versus insert. So I'm creating a table. Probably it already exists. I'm creating a table. It already exists. So let's drop the table. I'm calling it big table insert. And I'm recreating it now. So now, because I want to show you the difference between insert and select into, what I'm doing, the table is already there. I'm going to do a select into, so I have an insert into that table here. And I have I'm going to drop this one also. This is a table that I have. Okay, so here I have a select into big table fast. So select the same exact columns, but with select into. So let's put this in comments. So I just want to show you the difference between insert and select into. So from the execution plan, insert, you see the insert is going to be much more intense, okay, 78 versus 22. But if we also add the set statistics on, and you will see that even though they're doing the same thing, they're both querying from big table everything from big table, it's going to be better the select into. So let's execute. So one is insert and the other one is select into. And we're just going to insert everything, the entire 10 million to both. Okay, so the first one is done. You see, 10 million. The second one is done much faster. And why? Because no transaction log, and also it's much faster because it's only the select. It doesn't have to do any insert. So you can see that if you run them separately, you will see that one is running, the insert is running much slower than the select into. Let's talk about delete versus truncate. So I'm going to use the same exact tables. The first one, I'm going to delete 10 million rows, and the second one, I'm going to truncate. Okay, let's do it inside a transaction. So let's begin transaction delete. You know what? I'm going to show you the begin transaction only for the truncate. So let's delete. It's going to take us a long time, right? It's going to take us because it's deleting the entire table. Maybe I don't want to show you everything. Let's do this in another window. I'm going to truncate the other one. So begin transaction, execute. Let's do rollback. Let's see how many rows I have in that table. You see? So it's still part of the, it can be part of it, of the transaction, but it's very, very, very fast. And this one took 15 seconds. So truncate, much faster. Okay, so what did we see? We saw select into versus inserts, delete versus truncates. Let's continue. So data types. Data types are very, very important, the way you choose your data type. Let's remember that SQL Server is keeping information of indexes and tables in pages of 8K, where you have a page header, then you have the rows, and then you have the rows offset. So imagine that you have a specific column that has nulls in them. The null does not take any space. And let's say that you update now from null to a value. That means that the row has to expand in the page. So eventually you will run out of space in the page if you're expanding a lot of data. And what will happen is that this page will have to split into two. Those page splits are very resource intense. So we need to make sure that we're trying to avoid this. So it's not just that, it's also that if you have indexes, the indexes will become fragmented because you're splitting page into two, so you have more space in the index. That means that all the IO operations are going to be much more expensive because you're going to read more pages, okay? And it's also, data types are also important when you're doing comparison between tables in queries, between different data types. So sometimes, you know, if you want to compare between integer and numeric, or any other data type, sometimes SQL Server, because it's not the same type, it will have to do an implicit conversion, and it is not, probably it's not going to be able to use indexes that way. And if it fails, you will have to put a function to do an explicit conversion, like convert or cast, and then anyway, SQL Server will not be able to use the indexes. So try, if you are comparing between columns, make sure that they are of the same data type in your database design, and try to avoid page splits as much as you can. Also, try to use sequential clustered index, because when the clustered index, because the clustered index is actually sorting your table on the disk based on the key. So if it's not sequential, rows are going to be starting to be inserted in between and going to also cause page splits and fragmentations. Okay, so try not to do that either. I'm not going to show the demo, we're running out of time. I'm going to continue with the other best practices. So try to use try and catch blocks because you want to trace errors, you want to be able to trace errors better. Transaction handling, this is very important. So you have different types of transactions. You need to make sure rollbacks are very resource intense. So you need to make sure that your rollbacks are only rolling back if it's absolutely necessary. So I do have one thing in the demo where I show a big transaction that is happening, and then if the row count was not exactly that, rollback. So this is a very bad practice. So don't use rollback as part of the logic. Use rollbacks only if you had an error. Okay, so this is very important. Snapshot isolation level is very important, and it can help you prevent blocking. If you have a database that that has blocking, locking, and deadlocks, you can try the snapshot isolation level. You can read about this. But if you have transactions that explicitly changing the isolation level to, let's say, serializable or read committed, the snapshot isolation level will not help. So I had a client where we moved to snapshot isolation level, but from the application, they were sending transactions with isolation level serializable, and they were still blocking, they were still causing lock blocks and deadlocks. Okay, so you need to make sure that the transaction handling is not different than what you decided on the database side, unless it's necessary. You can use optimizer hints like no lock and row lock. So no lock will read the data, dirty data, and will not wait for the locks. So even if you're currently updating the data, it's going to fetch the dirty data before the update. And row lock, when you're updating with row lock, it will make sure that you're locking the specific rows that you're updating, but not the pages, because SQL Server, because locking is also a resource consuming mechanism. When it has to, sometimes when it has to lock too many rows, it will start locking pages. And if it's too many pages, it will lock the entire table to ensure that the operation is going to be faster and the locking mechanism is not going to be an overhead. So you can tell the optimizer, you know, give me the query with no lock, then I ignore locking, or update or delete with row lock, meaning that other operations are not going to be blocked by my operation. I'm not going to show the demo because we are already out of time. Let's go fast and discuss the other main best practices. Eager pull is when, for example, you have an index on a column and you're modifying that column where that column is between values. That means that meanwhile you're doing the operation, the values in the index are changing. So the row may be moving in the index. So that means that SQL Server needs to always review the new location of the row. So read about it. It's something very interesting. So when you see eager pull, this is not a very good sign. It means that you're changing, you're modifying results that SQL Server needs to redo or review where they are after the operation. I'm not going to talk about the schema binding. Schema binding is just when you create objects that require, it tells SQL Server that the objects that a specific view or subprocedure rely on, they cannot be modified because it's important to keep the structure. So for example, if you have a view and you select star from a table, if the table changes, the view may fail if it doesn't have if it doesn't touch the right columns. If, for example, a column name changes, the view is still there. The operation will not fail unless the view is defined as schema binding. We talked about index hints, like you can tell the optimizer use this index hint or the other, but we need to be very, very careful with that because probably if SQL Server uses an index, it's probably because it should have. So when you add any hint, make sure that you monitor and you ensure that, let's say, for newer versions of SQL Server, this hint is still a good one. Okay. Another one is different collisions. So you can have columns with different collisions, and operations may fail because of the collision, because it cannot compare between two different collisions sometimes. So you will have this error. And again, we're not going to have time for a demo. Few more. Use the query store to review the regressive queries and all kind of information that the query store can give you. Try not to use three-part names. So three-part names, if you have two databases under the same instance and you call a different database from your database, that means that your two databases will have to always be together. And you cannot actually migrate this database to a PaaS solution, because in a PaaS solution, the database is an independent entity. Link servers, like I said, link servers are unique in a way that the local optimizer does not recognize the remote one. let's go fast with everything. So, for example, if you have select something where a column in and you have a lot of values, I've seen that coming from an application. Sometimes the optimizer doesn't know what to do with this when you have, for example, where column in 1, 2, 3, 4, 5, 6. So you have a big list of values. The optimizer will not know what to do with that. It will not be able to use an index, and so it will be a table. It will use a table scan. As a solution, you can just create a temporary table with those values and just join. So it can use an index. Another big tip is use identity scope instead of identity, because if you call other store procedure, if you call, if you have nesting, then identity is going to change. So you need identity scopes that is going to give you the identity for this session, the whole session, and not for the only the piece of code that you have. More best practices. Always try to use select top if possible. Try to avoid distinct union order by, because there's sorting operation, and sorting operation are very resource consuming. Merge, intersect, and accept are very, very resource consuming operations. If you have a problem with those operations, try to find solutions to write in a different way. Okay, especially merge. One more thing here is index views or materialized views is views that on which you can create indexes. If they are involving more than one table, you may cause deadlock because of the way the view is going to be on more than one table, and then there may be other processes accessing those tables, and you may cause deadlock. So be very aware of that. Try to access all the objects in the same order to avoid deadlocks. Monitor your deadlocks and make sure that because deadlocks are very heavy for the database. If you have, the more indexes you have, the better the queries may be, but the data updates are going to be much slower. So you need to decide what are the indexes that you really need. If you look at the DMVs, there are DMVs that are telling you what are the indexes that are not being used and are heavy, what are the indexes that are missing, and a lot of information about the indexes. And this is it for now. I have a lot more to say. I'm already running late, and I will be happy to get more questions from you or comments. These are my emails. I want to thank Microsoft for supporting this convention, and also the data platform. And don't forget to win prizes. So I really hope you enjoyed this presentation, and see you soon.